Hello, you're welcome to Study Guide Forum, and we have a question. But before then, I want to thank all of you that all our subscribers. We want to thank all our subscribers and people that have been taking time to study with us, and also we want to encourage those that have not subscribed to subscribe, and also um, I want you to like, share, and also comment. So in this case, we have a question we want to look at. This question says the metal wire of a mass 2 grams and length 60 cm is under tension of 50 Newton. So calculate the fundamental frequency. The second question is the first and second overtones. And the last question there is the speed of transverse wave in the string. So in this case, we're going to let's look at the question. Remember, in string, the fundamental frequency is getting, you can get it with this formula: tension over m, T over m. Where this one is where L stands for the length. The length is what? 6 cm, which is equal to 0.6 meter, which is equal to 0.6 meter. And we have our tension. Our tension is 50 Newton. Also, we have, for this one, we have the m. Our m here is equal to the mass divided by, which one is the mass there? The mass is 2 grams. The mass is 2 grams. Mass is what? 2 grams, which is the same thing as 0.002 kg. 0.202 kg. And then the m will then be 0.002 kg over what? 0.6 meter. That will give us 0.0033 kg meter. So since we have all these things, the next thing we are going to do is to substitute each of them in the formula. So if we substitute we'll have the fundamental frequency is equal to 1 over 2 bracket 0.6 square root of the tension, which is 50 all over 0.0033. So that will give us 1.2 square 1551.5. So our final answer will then be 102.5 Hertz. 102.5 Hertz. That's our fundamental frequency. We have our fundamental frequency. Now we say that we should find the first and second overtone. The first overtone is first overtone is 2 times fundamental frequency. So the first overtone is 2 times fundamental frequency, while the second overtone is equal to 3 times fundamental frequency. So what we do here is that we multiply. For this one, we have 2 times 1 0. I think this page might not be very wonderful for it. Alright, we have that will give us 2 times 102.5, which is equal to 0.205 hertz approximately. And the second one, the second overtone is equal to 3 times 102.5 equal to 308 hertz approximately. The last question there said that calculate the speed of a transverse wave in the range. So the speed of the transverse wave in the range can be calculated using the, I still have my fundamental frequency there. Now I'm cleaning up everything. So we talk about the velocity, which is the speed there, fundamental frequency over lambda. So, and our lambda in this case is equal to 2 times what? L. So 2 times L will give us 2 times 0.6. That will be 1.2. So then the next thing we do here is that we multiply it with our fundamental frequency. Which is 102.5 times 1.2. That will give us 123 meter per second. That's the final answer. Thank you so much for watching, and we hope to see you in our next video. And then we hope you subscribe if you have not, and then you like and share. Thank you so much.